Unit 2, Minerals and Rocks. We're doing Lesson 2 and Lesson 3 today, classifying rocks and igneous rocks. By the end of this lesson, we'll be able to list the characteristics used to identify rocks and identify the three major groups of rocks, one of them being igneous. And we'll be able to identify the characteristics used to identify igneous rocks and describe ways in which igneous rocks are used. So Lesson 2, Classifying Rocks, My Planet Diary, Field Trip. The Lonely Giant. In the midst of Wyoming stands a lonely giant, Mount Moran. Its peak stands more than 3,800 meters above sea level. If you climb Mount Moran, you'll crawl across slabs of rock. These slabs formed deep beneath Earth's surface. Here, great temperatures and pressures changed one type of rock into the rock of the slab. As you continue to climb, a thick vertical strip of darker stone suddenly appears. This rock is volcanic rock. Finally, when you reach the top, you find a 15-meter cap of sandstone. This rock formed when many tiny particles were squeezed tightly together over millions of years. So Mount Moran contains rocks that formed in three different ways. So if we're climbing this little tiny mountain here, and we wanted to know how we could tell one type of rock from another one, well, the rocks are made up of different material, they have different strips, they might be slightly colored a bit differently. All this we're going to talk about coming up. How do geologists classify rocks? If you were a geologist, how would you examine a rock for the first time? You might look at the outside surfaces, but you would also probably use a hammer to break open a small sample of the rock and look inside. To study a rock sample, geologists observe the rock's mineral composition, color, and texture. Rocks are made of mixtures of minerals and other materials. Some rocks contain only a single material, or a single mineral. Other rocks contain several minerals. The granite in Figure 1, for example, is made up of quartz, feldspar, mica, and hornblende. About 20 minerals make up most of the rocks on Earth's crust. These minerals are known as rock-forming minerals. The minerals that make up granite are rock-forming minerals. A rock's color provides clues to the rock's mineral composition. For example, granite is generally a light-colored rock that has high silica content. That is, it is rich in the elements silicon and oxygen. Basalt is a dark-colored rock that has a lower silica content than granite has. But unlike granite, basalt has mineral crystals that are too small to be seen with the naked eye. As with minerals, color alone does not provide enough information to identify a rock. So here at the bottom we have a picture of what a granite rock is. It's generally made up of only a few common minerals. We can see that it's showing us we can find mica, we can find quartz, hornblende, and feldspar all throughout this rock. Question says, how would you describe the overall color of the rock? What minerals cause the color or colors that you chose? Well, I can see by looking at this rock, it looks like it's spotted with many different colors. We've got some black in there, which probably comes a bit from the hornblende, maybe some of the mica. We've got some pink in there that could be the feldspar, and we've got some gray in there that could come from the quartz. Most rocks are made up of particles of minerals or other rocks, which geologists call grains. Grains give the rock its texture. Texture is the look and feel of a rock's surface. To describe the texture of a rock, geologists use terms that are based on the size, shape, and pattern of the grains. We have grain size. So rocks with grains that are large and easy to see are said to be coarse-grained. Fine-grained rocks have grains that are so small they can only be seen with a microscope. So this is a zoomed-in piece of some rocks. Our fine grain is like slate. It's like flat. We don't really see any spots on there. Coarse grain is diorite. So we can see there's a lot of spots that are on here. the grains are really big. And flint has no visible grain, which means that we'd have to like zoom in on a microscope, and there's not really a set pattern to it. Grain shape. In some rocks, grain shape results from the shape of the mineral crystals that form the rock. Other rocks have a grain shape that result from rounded or jagged bits of several rocks. So we have rounded grain, which looks like conglomerate. They're all a little rounded a bit, kind of looks like small rocks. And we have jagged grain like breccia or breccia, I don't know, that look like they've been cut apart a bit. Maybe it fell and it broke. And we have grain pattern. In banded rocks, grains can lie in pattern of flat layers or can form swirls or colored bands. Non-banded rocks have grains that do not lie in any visible pattern. So we have non-banded, which looks like quartzite. Doesn't really look like there's a pattern to it. The grains don't really look like they're swirling or in a colored band. And we have our banded, which is like our nice rock over here. That's nice, yeah. And you can see the strips of dark black that are making our grain pattern. So down here at the bottom, we have a picture of a rock. Photograph shows part of a coarse grained rock. Read the text on the page, answer the questions. We've read the text on the page. Is this rock banded or non-banded? Are there visible lines that lie in a pattern of flat layers or swirls on the band? Yeah, it does. You can definitely see the dark black lines that are shaping it. This is a banded rock. Based on this rock's appearance, what type of rock might this be? Well, we have some rocks up above. The one that looks closest to it would be gneiss. Hey, it says gneiss forms when very high pressure and temperature are applied to existing rock. How might these conditions explain the wavy patterns of this rock? Well, the great temperature and pressure could have made the existing rock behave kind of like plastic when you melt plastic and it bends a bit. So it would reshape the rock to form the bands. Using the characteristic of color, texture, and mineral composition, geologists can classify a rock according to its origin. A rock's origin is the way that the rock was formed. Geologists have classified rocks into three major groups: igneous rock, sedimentary rock, and metamorphic rock. Each of these group of rocks forms in a different way, as shown in Figure 2. Igneous rock forms from the cooling of magma or lava. The magma hardens underground to form rock. The lava erupts, cools, and hardens to form rock on Earth's surface. Most sedimentary rock forms when small particles of rocks or the remains of plants and animals are pressed and then cemented together, where we get sedimentary cemented. Sedimentary rock forms in layers that are buried below the surface. And metamorphic rock forms when a rock is changed by heat or pressure or by chemical reactions. Most metamorphic rock forms deep underground. It says, using the sentences we underlined, we didn't, but it's the definitions. Label each diagram with the rock origin it represents. We have a wavy looking rock origin. We have what looks like a volcano, and we have flat lines. Well, we know that metamorphic forms when a rock is changed by heat or pressure or by chemical reactions, and they form way deep underground. So the first wavy boy would be our metamorphic rock. There is pressure, there is heat that is crunching together, making this rock. We know igneous forms from the cooling of magma or lava. Which one of these shows magma and lava? The middle picture with a volcano. So that is what igneous is. And then sedimentary, they say they are pressed and cemented together and they form in layers. So the final one that looks like we have different layers, not all smushed together, but just flat, straight, like little blankets. That last one would be sedimentary. Let's go talk about igneous rocks. Igneous Rocks My Planet Diary Discover Arctic Diamonds. If you were looking for diamonds, where would you start? Maybe in a helicopter flying over the Arctic Circle? In the 1980s, a pair of geologists used a helicopter to search for diamonds in Canada. The pair knew that diamonds form more than 100 kilometers under Earth's surface. They also knew that after diamonds form, powerful eruptions of magma can thrust the diamonds to the surface through volcanic pipes. As the magma cools and hardens, the diamonds are trapped inside the volcanic rock. The geologists found a source for diamonds after searching for several years. Now, diamond mines in Canada produce one of the world's most valuable crop of diamonds. Okay, but how do geologists classify igneous rocks specifically? In a second, we'll look at Figure 1. All of the rocks that are shown in Figure are igneous rocks. But do all the rocks look the same? No, because even though all igneous rocks form from magma or lava, igneous rocks can look vastly different from each other. Igneous rocks are classified by their origin, texture, and mineral composition. At the bottom we here have the 3 different rocks that are igneous rocks but look slightly different, and we will talk more about those in a second. So we said igneous rocks are classified by their origin, texture, and mineral composition. Igneous rock may form on or beneath the Earth's surface. Extrusive rock is igneous rock formed from lava that erupted onto Earth's surface. Basalt is the most common extrusive rock. Igneous rock that is formed when magma hardened beneath the surface of the Earth is called intrusive rock. The most abundant type of intrusive rock is continental crust is granite. Granite forms tens of kilometers below Earth's surface and over hundreds of thousands of years or longer. So extrusive is igneous rock formed that has been exited from Earth's surface, and intrusive is igneous rock that is formed in and beneath Earth's surface. Different igneous rocks may have similar mineral compositions and yet have very different textures. The texture of an igneous rock depends on the size and shape of its mineral crystals. The only exception to this rule are the different types of volcanic glass, igneous rock that lacks a crystal structure. Rapidly cooling lava forms fine-grained igneous rocks with small crystals or no crystals at all. Slowly cooling magma forms coarse-grained rocks such as granite with large crystals. So intrusive and extrusive rocks usually have different textures. For example, intrusive rocks have larger grains than extrusive rocks. Extrusive rocks have a fine-grained or glassy texture. Figure 1 shows the textures of different igneous rocks. So here we go. We need to find out, did they form inside or outside of Earth's surface? Are they extrusive or are they intrusive? We have porphyry. The porphyry shown here has large crystals surrounded by small crystals. Where did this crystal form? This rock probably formed inside. It says intrusive rocks have large grains. That looks like it has a large grain in it. So inside, letter B. We have pegmatite, a very coarse-grained, intrusive igneous rock. Well, they told us already it's intrusive, so it formed in B. And we have rhyolite. Rhyolite is a fine-grained, extrusive igneous rock with a composition that is similar to granite. Granite, we know, is intrusive, but this rhyolite is extrusive, so A. A, formed on the outside. Recall that the silica content of magma and lava can vary. Lava that is low in silica usually forms dark-colored rocks such as basalt. Basalt contains feldspar, as well as certain dark-colored minerals, but does not contain quartz. Magma that is high in silica usually forms light-colored rocks, such as granite. Granite's mineral composition determines its color, which can be light gray, red, or pink. Granite that is rich in reddish feldspar is a speckled pink. But granite rich in hornblende and dark mica is light gray with dark specks. Quartz crystals in granite add light gray or smoky specks. So at the top we have apply it. Diorite is a coarse-grained, intrusive igneous rock. It is a mixture of feldspar and dark-colored minerals such as hornblende and mica. The proportion of feldspar and dark minerals in diorites can vary. So in this picture here, we have one example of diorite, but there are many different kinds. It says, what mineral is most abundant in this sample, illustrated by the graph? Well, we can see which one's taking up the most space on our pie chart. Feldspar. So that's the mineral that is most abundant in this specific piece of diorite. Our challenge question is, how would the color of the diorite change if it contains less hornblende and more feldspar? Well, perhaps that it would have, feldspar we know is a lighter mineral and hornblende is a darker mineral. So if we had less of the hornblende and even more of the feldspar, it would probably make the rock lighter. Not heavy-wise, but color-wise, it would look a lot lighter. How are igneous rocks used? Many igneous rocks are hard, dense, and durable. People throughout history have used igneous rocks for tools and building materials. Granite has a long history of use as a building material. More than 3,500 years ago, the ancient Egyptians used granite to build statues. About 600 years ago, the Incas of Peru built fortresses out of great blocks of granite and other igneous rock. You can see part of one of their fortresses at the bottom here in Figure 2. In the United States during the 1800s and 1900s, granite was widely used to build bridges and public buildings. Today, thin, polished sheets of granite are used in curbstones and floors. Another igneous rock, basalt, can be used for cobblestones. It can also be crushed and used as a material in landscaping and in roads. Igneous rocks such as pumice and obsidian have also important uses. The rough surface of pumice forms when gas bubbles are trapped in fast-cooling lava, leaving spaces in the rock. The rough surface makes pumice a good abrasive for cleaning and polishing. Ancient Native Americans used obsidian to make sharp tools for cutting and scraping. Obsidian cools very quickly without forming crystals, so it has a smooth, shiny texture like glass. Perlite, formed by the rapid cooling of magma or lava, is often mixed with soil and used for starting vegetable seeds. And there we have it. That is what igneous rocks are. So in our next couple lessons, as we finally finish science for the school year, we'll be talking about sedimentary and metamorphic rocks. See you then.